Hello guys, this is Wits Lounge, Learning Made Easy, and in today's video we are going to be understanding a very important concept, which is the acids and base. Before we get into the study, please like, share and subscribe. So let's get into it. Bronsted and Lowry, on the other hand, discovered that there are some substances that do not necessarily ionize to produce hydrogen ion. However, they exhibit acidic properties. Hence, they both put their heads together to give a different definition of an acid and a base. So, a Bronsted-Lowry acid is simply defined as a proton bracket hydrogen ion donor. Take it again. A Bronsted-Lowry acid is simply defined as a proton bracket hydrogen ion donor, which means any substance that has the ability to give, not necessarily to ionize, but to give hydrogen ion, is automatically a Bronsted-Lowry acid. On the other hand, the Bronsted-Lowry base is a proton or hydrogen ion acceptor. So, which means that a substance doesn't necessarily need to have OH to be a base, and a substance doesn't necessarily need to ionize hydrogen to be an acid. Once you are considering acids and base with respect to Bronsted-Lowry's definition, a Bronsted-Lowry acid donates a proton, while a Bronsted-Lowry base accepts a proton. Okay, let's kind of consider this thing. Okay, now let's go to our screen, our board, take this whole thing out. Now imagine you have a reaction like this. NH4 plus HSO4 minus reacting to give NH3 plus H2SO4. The very first thing that comes to your mind when you see HSO4, most of you have thought about H2SO4. Immediately you saw HSO4, you're thinking H2SO4, and if you are asked to identify the acid here, most of you will go for this particular guy because it has a closer relationship to one of the most strong acids we know, which is the sulfuric acid. But that is not the case here. Let's look at what Bronsted-Lowry said. Bronsted-Lowry's definition of an acid is that it is a proton donor. So any of these two substances on the reactant side that donates a proton is an acid. On the other hand, any of these two substances that accepts a proton is a base. So let's consider that. Okay, we had that the ammonium ion here had 4 hydrogens, but then when it finished reacting, it now has 3. What does it imply? It implies that this particular ammonium ion lost a proton. It gave out a proton, it donated a proton. Hence, this is going to be our Bronsted-Lowry acid. Remember, Bronsted-Lowry acid, donor. Then on this hand, we have that HSO4 used to have 1 hydrogen here, and then on this other hand, it has 2, which means it accepted after the reaction. And what did we say is a proton acceptor, a Bronsted-Lowry base acceptor. So have that in mind, that whenever you see a reaction and that reaction involves the transfer of protons, the donor of protons is the acid, while the acceptor of protons is the base. You get what I'm saying? I used to make one joke usually, and I say that usually, if you notice, babe and base coincide. Why did I say that? Because a babe collects from the guy, so does a base in this case collect from the acid. So let's continue. Having said this, you'll notice that the ammonium ion transferred 1 hydrogen to HSO4, and then it became H2SO4. So basically that's that. Let's try one more example to help us understand this. Imagine I had H2O and then I had HCO3 minus. If this reaction is to occur and we have something like H3O plus CO3 2 minus, which one of them is the acid, which one of them is the base? Notice something. Water in this case has 2 hydrogen atoms, but when it crossed over here it has 3. Because it went from 2 and collected 1 more, it means that this guy is an acceptor. And what did we say about proton acceptors? Proton acceptors are Bronsted-Lowry bases. In this case, HCO3 used to have 1, but crossing over it does not have, which means it donated. And because he is a donor, this is what we refer to as a Bronsted-Lowry acid. So you have that. Easy to understand. Bronsted-Lowry acid donates a proton. A Bronsted-Lowry base accepts a proton. Please note, you don't just stop at the term donate. You are considering what it is donating, because this is exactly the difference between a Bronsted-Lowry acid and a Lewis acid, also a Bronzellari base and a Lewis base. Like, what differentiates definitions of Bronzellari and Lewis is simply what they are donating and accepting. We'll get to understand that as we go ahead. But before we get into Lewis, now, once you have that a Bronzellari acid donates a proton, the product after it donates a proton is what we call a conjugate base. I take it again. A Bronzellari acid will form a conjugate base, while a Bronzellari base will form a conjugate acid. So it's more like acid forms base and base forms acid. So have that in mind. The product formed after a Bronzellari acid donates a proton is what we refer to as a conjugate base. Then, after a Bronzellari base accepts a proton, the product it forms, which is this H2SO4, is now the conjugate acid. Okay, we're going to try out some more examples to help us understand this. I'm going to write a reaction, and we're going to identify the Bronzellari acid, Bronzellari base, conjugate acid, and the conjugate base. Okay, so imagine we have something like HCl plus NH3. Okay, so in this reaction, let's make it aqueous. Imagine this reaction now leads to the formation of Cl minus aqueous plus NH4 plus aqueous. Now, looking at these things, you will notice something. HCl here used to have one hydrogen, but then when it crossed over, it does not have any, which means that HCl gave away its hydrogen. The donor of hydrogen ion or proton is what we refer to as a Bronzellari acid. I now mentioned something, that this acid formed this guy. The product that is formed after a Bronzellari acid donates a proton is a conjugate base. So have that in mind. Acid forms the conjugate base, while the base will have to form the conjugate acid. Okay, so in this case now, this particular ammonia had 3 hydrogen atoms, but crossing over, you will notice that after the reaction it has 4. What does it tell us? It accepted one more. And what is the implication? Because it is an acceptor, we are going to refer to this as a Bronzellari base. What did we say about a Bronzellari base? A Bronzellari base would form a conjugate acid. I hope this is quite understood. Now, one other point, or one other reason is important for you to know a Bronzellari acid base and its conjugate is that it is a very important factor in your buffer solutions. Yes, your buffer solutions are basically a mixture of a particular acid and its conjugate base, or a base and its conjugate acid. We'll get to understand this as we go further in this study. Now, before I leave Bronzellari's definition, it's important to note this, just so you could write this down. The difference between a Bronzellari acid and its conjugate base is 1 proton. It also applies to the base. The difference between a Bronzellari base and its conjugate acid is 1 proton. So that is to say, a Bronzellari acid has 1 hydrogen more than its conjugate base, and a Bronzellari base has 1 hydrogen less than its conjugate acid. I presume we've actually learned a lot in this class. Remember, this is Woods Lounge, learning made easy.